In our last class, we discussed how to create this animation. Let's take another look. We achieve this effect without having to reset the weights, but the problem is, these little blocks, they stretch. So how do we deal with it? First of all, our object here is a very ordinary model. We'll start with a small block and clone it based on that. Make this little yellow box very small. Let it come together in the form of objects. Now, there are more small squares. Now let's scroll down this little block a bit. Let's move in for a closer look. We can see that each cube has 8 corners, and each corner will generate a small cube. Why do these little blocks squeeze together? We can see a lot of little blocks. They are all squeezed together. We have several points here, all squeezed together, thus forming these blocks which also clump together. We watched as A selected the customer object's entire aspect. Right-click to scale along the hairline. We can make it a bit smaller. So we click on the grid, click Initialize again to constrain it once more. Playing it again, you can see all those little blocks have shrunk. Now, the blocks we clone won't be so tightly packed inside the clone. We turned off the Arrange Clone feature. Now, this effect is going to be much better. We choose to clone one of all the faces, slightly increasing the scale with the normals. Initialization. Let's hide the dragon below by pressing the Alt key and then play it again. It seems a bit better now than just before. At this time, we add a ground to our guest communication object. For example, adding a simulation label inside, we add a rigid body. Within the dynamic stimulation, we can enable collision. We click to collide. There will be many parameters involved. We apply the system tag to our standalone element. We change it to all. Now, we can see these small cubes falling and hitting our ground. Let's add one. Simulating to collider of attack. You can see when this character moves, this little cube will fall down. Of course, this effect is not what we want. Let's analyze it by first removing its dynamics.
Subtitles by Li Zhengsheng.
What's the issue? Well, these small cubes are obviously like mosaics, tiny squares. Piece by piece. This is not what we want, Each one consists of 8 small cubes, looking as though they're one and the same, as we see in our final effect. It's not that our final effect. This effect is much better, not squeezed together. Let's analyze where the problem lies, and then we'll shut it down. This is because the cloned blocks are based on the Clone 1 modeler, within which every block contains 8 points. So it generated 8 small cubes. Its movement, rotation, and scaling are exactly the same. Let's take another look. This is the problem we are talking about. What we want is that each small cube is independent and very free. At this point, let's talk about a concept in 3-dimensional software. Any object is made up of points, lines, and surfaces. Lines are made between 2 points, and areas are made between lines. Faces together form a solid. It looks like a cube, but its inside is empty. Actually, it is made up of 8 points. By pressing the C key, which stands for cut, we turn it into an editable object. After turning it into an editable object, we are here. There's a term called construction. When we click on construction, we find it's made up of 8 points. Each point has an order consisting of 8 points. In clone mode, we can freely delete any point. Deleting a dot differs notably from Facebook and 3 other applications in a very special way. I remember, whether it's in Maya or in 3ds Max, if we delete the surface of a model, like when we choose a surface, when we delete its surface, the software will automatically delete its lines and its points. That is to say, individual points cannot exist on their own. In C4D, when we delete these faces, the points still exist, which is quite amazing. And that's a very good thing. Alright, let's now delete this sphere. Let's also delete this cube, and then demonstrate again by creating a new cube and pressing the C key to cut it into an editable object. Then, within the grid, we find and reset the pivot point. To each his own. We target its center point. Change XY hazard to -100%. Now its pivot point is right here. Alright, let's click below the frame. We remove these 4 dots now. We remove these 3 dots. Well, our cube still has its points. Let's rename it. Just call it point. That is to say, now this cube has only 1 point left. Let's copy it. We go inside and paste quickly. So, what should we do? Let's turn off the possible object. Now, we see this object. We drag out the cube, not letting it clone the cube. We let it clone the point. Right now, although we can't see anything, it's okay. We have seen the current state turned into an object. By pressing the Alt-K, we can conceal it, revealing many dots within. We select these points. Hold down the Shift key to select all points. Right-click plus delete. We still can't see anything. But that doesn't mean it doesn't exist. What is it? It's a bunch of points. Let's quickly pick it. It's so many points. So now it's good. It's really good now. How do we deal with it? We let this grid affect the clone object 3, generating a bunch of points.
Thank you, everyone.
It's renamed to a bunch of dots. It's still the animation from before. Initializing it properly is very important. You must click to initialize. At this time, these dots will move, though we can't see them. Alright, let's show the clone symmetry now. We clone it based on what? We clone it based on the bunch of points we just generated. Then, we enlarge this small square a bit. It's absolutely perfect. What we see now, these little cubes, are controlled by these points. No problem at all. Arranged very comfortably. Very orderly, not at all messy. This point is very important. Let me emphasize again. In Facet, each dot can exist independently. Now, how do we make its color look really good, as rich and pleasing as we see now? At this point, we all know there's a very important effector in C4D called the shader effector. It can color our little squares after embedding. In some situations, it makes the small square bigger, indicating visually that it is functioning. Now I'll turn it off. Inside the shader, we can choose a texture. Now, I've found a texture here, so let's choose this one. After selecting this texture, we can see its color has become very rich. But if we play it, you'll notice it flickers, and the effect we want does not involve it flickering. What we hope is that if it's a yellow square, we want it to always be yellow, not flickering. But in reality, it does flicker. Let's analyze why it flickers. To understand why it flickers, we need to know how the shader works. At this time, let's explain another concept called UV. And first, we start a project. Any plane, which includes points, lines, and surfaces, becomes editable when we cut it using C. We can see this. It is composed of dots, lines, and surfaces. There's information we can see, and another kind we can't right now, called UV. UV is like coordinates. It has direction. It has dimensions. And if we talk about this object, when we calculate its area, after deleting everything, it only leaves these dots because there is no UV. It cannot store UVE. Now, we're entering the character animation section. And the shader effect, what is that based on? It's based on the negative clone of our object. But who does the cloning? We use this bunch of points to come closer together. The shader will adjust accordingly.
A bunch of dots UV coming at
Our
me.
formal object here, give it a color, because these dots are just a bunch of dots without UV. And without UV, it will cause a problem. For us clones, this little cube, it's like it has no soul. If we add a shader effect to it, there's no way we can't fix this color. Students with a weak foundation might find this quite challenging, but no worries. We will cover the knowledge in this lesson. We will have very detailed explanations in the later courses. Now, we need to find a way to generate all these points.
The end.
How do we do that? Let's introduce another concept. Let's test the plane first. Then, we create another sphere and place this sphere here. For this sphere, we still cut. Press the C key to select planar symmetry. Let's introduce another concept. What is it? It's transformation. We can let the points of this flat object find the points on a sphere. What does that mean? In this plane, every point will have one. In the ID structure, we can see the first, second, third, and fourth points. That's its ID. The sphere, it too will have an ID for the first point, the second point, the third point. What is deformation? For deformation, we let the first base of the plane find the sphere's first points. Set the plane's second point equal to the sphere's, which is the position coordinate. We select the plane and then add to it. In the role text, we find the posture transformation. Then we select points. When we unfold advanced properties, there will be an objective, meaning we make it follow our sphere. At this moment, we change its intensity. We'll find that the points on the plane will form a spherical shape, but they haven't adapted to the position of this sphere in space. In the basic properties, we check the position. Location, rotation, and scaling can now be observed. It completely fits. Why is it that this flat plane doesn't correspond one-to-one? It's because the sphere we are choosing now doesn't have as many points as the plane. We randomly select some surfaces and add subdivisions to them. You see, the points on the plane automatically correspond with it one by one as we continue to subdivide. Now, it completely corresponds one-to-one. We can transform this plane into a sphere by controlling their vertical. This is postural transformation. Postural transformation is also very important, and we have detailed explanations in later lessons. Well, now we continue to enter character animation. What do we want to do? We turn off the lights in the guest building, and also those on the desk. We now have so many points. We click on construct, and inside, we can see how many points there are in total. 552 points.
Let's fry noodle first.
Tilt the plane up a bit. We cut the plane once, and after cutting, we click to construct. Let's see how many dots there are. It has 440 volts, meaning it's not up to 552 volts. We are in the area change mode, where we randomly select some surfaces and subdivide them. Let's see how many dots it has now. It has more than 600 dots. Well, its dots exceeded 500. Let's delete one.
We need to delete dots.
There are 573 points now. We continue to delete 570. 565 points. Let's delete 461 points. Okay, that's enough points. Let's add to this plane. In the character,
Alright,
we look for
no
the
need to sign.
posture deformation tab. We tick the dots.
We check the points.
For position, rotation, scaling, we check all, no problem. In the label, we need to tell it who you are looking for. You are looking for a bunch of points. Now, it will say more. I'll say, it will locate these points and animate them. As you can see, some spots never move, meaning that there are too many of them. Let's click a few more times and delete these spots. There are also some dots here that haven't moved, meaning it hasn't found the object it's referring to. Let's delete it.
The above statements do not represent the position of this station.
Delete.
Disperse.
See you next time.
Stay tuned, ito. Now, there are no problems. All these points have found their following objects. Alright, let's now display the cloned object and have it clone using our current plane. Then, by holding the Alt key, we hide this shield.
Regarding
So,
clones,
it hasn't changed at all because these spots are still the same spots. But what's different about
That's
pitfalls
all.
and strategies? It's just that our
Really?
plane still has a bit of a linear aspect. Just like a plane, it has dots and lines. Having dots and lines means it has UV. With UV mapping, only then can our shader fix the colors in place. Okay, let's play it again. You can see the color now. It doesn't flicker at all. It just sticks there, static. So at this time, what have we achieved? We have made it so that this character has small squares, perfectly fills in, whether it's inside or outside. It's neatly arranged together, and these little squares will animate along with our character. Small squares will have colors on top. The colors are different.
he will follow our character.
At this point, our preliminary animation has been explained up. In our next lesson, we will delve into the dynamics section within this shot. There are many techniques in the dynamics section. This class covers a lot of content, so if your basics are weak, you might not understand or keep up. No, don't worry, our later courses will cover everything in detail.